Oh, hello. Hello. Are we live? Are we live? Yeah, we are. Hello, hi guys. Good morning. If someone is there, then okay, we have Bennett, we have Siddharth. Can you guys please quickly tell if everything is fine or not? We have viewers, we have Supreet. Hello. Hi, Supreet. People joining in can just write down and yeah, let's have likes. We will see all 4 questions. Fourth one is actually complicated in general, but the one which we want to see, this one, it's actually easy. But yeah, in general, the fourth can get super complicated. So, भैया vlog मस्त था. Thank you, bro. Abhi, yo, Abhi. Hi. Let's quickly, the people joining in, just quickly write down hi, hello. How many questions you solved? What was the contest? How was everything else? We'll quickly start off with the first question itself. I don't want to jump in quite a lot because I need to leave early. I have important conversations going on. So let's quickly jump on to the first problem itself. But yeah, भैया कॉन्टेस्ट में तो क्वेश्चन करी, थर्ड क्वेश्चन के बाद हो गया, फोर्थ नहीं हुआ, cool, नो वरीज. भाई सेकंड क्यू फिनिश कर दो प्लीज. Cool. Harshvardhan, hi. Cool. Let's quickly jump out the first problem itself. It's pretty easy. It's the first, right? Okay, yeah, it's first. Cool. But before that, if the folks are joining in, can we reach 15 likes? 15 likes. Folks are 19. We're gonna see all 4 problems for sure. Let's quickly jump on to the first question. But yeah, let's quickly reach to 15 likes. That would be great. Check if the number is fascinating or not. We are having an integer n and that consists of 3 digits. Now, okay, exactly 3 digits. Cool. We call the number n fascinating if after modification the resulting number consists of all digits from 1 to 9 exactly once and does not contain any zeros. So basically, after that, making that fascinating number itself, it should contain only the numbers from 1 to 9 exactly once, and also it should not contain a zero. Cool. Concatenate n with 2 into n and 3 into n. So basically, if we have a number n, we will make a number 2 into n, we will make a number 3 into n, and then I have to concatenate all 3 numbers. Let's say if I have a number as n as 192, so I will get 192, concatenate with 192 into 2, which is 384, and then concatenate with 576, and then we'll check all the numbers in here should be one, like should be exactly once, right? 1 to 9, and it should not have any zeros. So simply just do one thing, get all the numbers, which is n, 2 into n and 3 into n, concatenate all the numbers down, and then just simply check that every digit, which means 1, 2, 3, should occur exactly once, and also there should be no zeros. That is simply a brute force solution for this problem. Just quickly see the code. It's super easy. Just quickly getting all these strings S1, S2 and S3. You can have any kind of implementation for this. It's just one thing I just showed, and then it's just very easy, like whatsoever. See, for these brute force kind of questions, whatsoever come in your mind, just quickly solve that out, and that would be it. Just get n, 2n, 3n, just concatenate all of them, and then go and find if every character is occurring exactly once. If it is not, then return a false. If it has already occurred, return a false. Or if that character is a 0, because I know that 0 can't be there, so for sure if that character is a 0, so simply return a false. And that's how we can simply solve the first question. Cool. Let's quickly jump on to question number 2. But hi, 3 solved. Cool. Bhai stack and Q finish. Cool. That will be great. Cool. Before going to the second question, let's quickly reach to like 20 likes. That would be great because we are going in super fast speed. Any doubts in between, anything whatsoever, you guys can quickly write that down. That would be super easy. Find the longest semi-repetitive substring. What that semi-repetitive means, it is nothing but you are having a 0 index string S, which consists of digits from 0 to 9. A string T is called semi-repetitive if there is at most one consecutive pair of same digit inside T. So basically I will get a substring 50, and then that is called a semi-repetitive if we have at most one consecutive pair of same digits, which means if the digits are same, let's say in this example 52233, we have same digit once, same digit twice. So basically it is having the same digits as twice, but I want these same digits to occur at most once, which means either none or maybe at max once. So I can have the longest substring as this 5223, which will have the consecutive pair of same digits exactly once, or maybe it is at most once. If it is like 54321, okay, we can choose this because it has having consecutive same digits as 0. So it should be at most once, at most one, at most one. Cool. Return the length of the longest semi-repetitive substring inside S. So what I will do, simply I look at the constraints. Firstly, constraints are pretty small. I can go and check for every substring. If n is my 50, I can go and check for every substring, which is n squared substrings. I can go and make a string. Okay, for these n squared substrings, I can go and make a string and check. Okay, if that string, if that substring made, if that is semi-repetitive or not, which means it should have the consecutive letter count, the consecutive letter which is same count as 0 or 1, which means the consecutive same letter count, it should be at most 1. If it is the case, just simply increment your answer by that, your maximum answer, which is the maximum length, because you want what? You want the length of the longest semi-repetitive substring. So to get the longest semi-repetitive substring, just simply go and check for every substring and choose the maximum length of all the substrings which are actually following the condition that consecutive element, same element count is actually less than equal to 1. Count is actually less than equal to 1. So simply go and make all the substrings, get n squared substring. For each substring, go and check if that substring is having the count of consecutive element as same as less than equal to 1. If it is, then update your answer, which is maximum of answer comma length of this substring, and by this you will get the length of the longest such substring. Cool. And that is how you can simply, by simply a brute force logic, you can simply implement this answer. But yeah, we'll quickly go on to question number 3, but before that, let's quickly jump on to the core of this question. It's simply a brute force implementation. But if you have not liked, let's quickly reach to 20 likes. Just 2 more likes, just 2 more. That would be great. We have the n, just simply the length of the string, main string, and then I have the answer which will have the longest length, and then I jumped on, okay, to get all the substrings. I jumped on to get all the substrings, which means a substring will be from I to j, just getting all the substrings. Now after I choose a I and a j to get a substring from I to j, I will get a temp, which is nothing but the substring from I to j. It is nothing but the starting index and the length. For sure, length will be j minus I plus 1 is the length. Then I have the substring called as temp. I will just go and check if that substring is semi-repetitive or not. And what is the condition for this? Is semi-repetitive? It is nothing but a function itself, which will go and check if the count of consecutive same element, which means the same character or same number, is actually less than or equal to 1. So I'll quickly go and check, okay, if that string which I passed in is semi-repetitive or not. I'll quickly go and check the length of that substring. If the length is 1, simply return true because 1 is itself semi-repetitive. But else, you can quickly go and check for every pair, which means I and I minus 1. Compare that I and I minus 1 and just see, okay, if that is same, which means I have 2 consecutive elements which are same. Increase the count. At last, if that count is less than or equal to 1, I have at most 1 consecutive pair, which is okay. Cool. So simply return a true. But if it is not, return a false. So if is a semi-repetitive function which will actually return me, okay, if that particular substring, which is here in case S, which I am passing in, is actually semi-repetitive or not. Cool. If it is, If it is, then simply convert and get the maximum. Okay, update your answer with the maximum answer. Answer will be nothing but maximum of answer, comma, the length of that particular substring which I passed in, which is the temp. Cool. Ultimately, I will just simply return the answer, and that is how you can simply solve this particular question. Cool. We'll quickly jump on to question number 3. That would be great. Right? That is actually a good question. It's a very see. If it's the first time, and yeah, meanwhile the folks are just watching, folks are liking in. We are actually on the question number 3 in just 10 minutes. So please, can we smash the like and reach that like count to 25 likes? That would be great. Cool. Nice. These all we can solve optimally using sliding window. Yeah, we can simply solve it, but why to put in much brains when we can solve it by simply using a brute force technique? Because for sure the constraints are pretty less. We can for sure solve it by sliding window because it just needs consecutive element and it's a concept of sub-array. Sub-array can be computed by sliding window itself, but still, it's a contest, and I'll highly recommend in a contest, don't put in much brains on optimizing unless it's required, which means unless the constraints say, because contest is more of how fast we do, not okay. It's not a daily question that okay, we have to optimize it completely. So I'll highly recommend. That's great. You thought of that, but yeah. We can solve it only. Yeah, question 2, question 4 was easier than question 3. Not exactly. Question 3 was much easier than question 4 because question 4 it can get super complicated. Question 4 can get super complicated. It's the constraints was n is less than equal to 5, which means the number of columns in question 4 was 5. If it would have been a 6 or more than it, that question would have rocked. Legit. That's super hard. Cool. Location Belendur. No, it is not. I'm also in Bangalore. Can we meet tomorrow? Not sure, bro, but yeah, we'll try to see. I don't keep meetups and stuff because I know for sure no one is gonna come. So that's the reason there's no point of me keeping meetup. By question 2 ka optimized way. See, you can optimize this question 2 by using sliding window because for sure you want a window such that consecutive elements, you can keep an I and a J. You can move your I as soon as you see, okay, this is a pair which is occurring. So next time I just want, okay, I will increment my range of that sliding window and I will just say, if that range, okay, if my I is here, let's quickly jump back. I'll just say, if my I is here, if it is a case 5, 2, 2, 3, 3, my I starting from here, my J moves on, my J moves on, my J moves on. Now, as soon as my next J is moving on, I need to keep track, okay, what was the last occurrence that my consecutive character came in? If it is, let's say this position, which is K, I will update this with the next location of K, which is I plus 1. And that is how I can update my range window like this. And I keep on moving my I and J one time only. And thus, by in O of N, only you can simply get your answer. But it's a bit hard to think in a contest runtime if you want to solve it in a minute or two. So that's the reason we can quickly solve it by using a simple brute force technique. Cool. Keep on doing this. Actually, I forgot to see the constraints in question 2. Cool. Same here, Ashutosh. Cool. Let's quickly jump on to question number 3. But meanwhile, can we reach to 30 likes? Just 3 more likes. That would be great. Movement of robots. Yeah. Firstly, before moving on to this question, it's a standard ANT question. Very standard. Very standard. It has quite a lot of modifications. I'll show the modifications and how complex this question can go. But it's a very standard. Please, if you have seen this, please remember it by a ANT question, not a robot question, because it's a standard ANT question. Cool. Let's quickly see. We have some robots are standing on an infinite number line. Mark my words, infinite number line with the initial coordinates as given by a zero index integer array called as nums. Cool. And will start moving once given the command to move. Okay, cool. Which means as we give the commands, it will move. Now, how will they move? Every robot. If we give the command as left, it will go on to the left which means in the negative axis, if we give the command as right, that robot will go on the right. Now what will do, as some robots are moving left, some are moving right, so if a robot is moving left or right, there's a high chance that these robots will collide. Cool. If they're moving in opposite direction, they will collide. Cool. Now if they will collide, now what will happen? We have to say, okay, at a time, which means after d seconds, what will happen? Return the sum of distances between all pairs of robots. All pair, mark my words. Sum of the distance between all pair of robots, I have to return in after d seconds after the command, which means as we given the commands as, okay, move left, move right, move left, move right. Since the sum can be pretty large, return the modulo 1 plus 7. Cool, no worries. It just say, okay, how the collision is taking place, but we know it just comes in, just goes back. It is how the collision is taking place. Cool. Let's quickly jump on to the first example itself. First robot is at -2, next is at 0, next is at 2. The first robot, it will move right, next will move left, next will move left. Now as you can easily see that these two will collide, and will opposite the direction. Again these two are moving in, again these two will collide and will again move in the direction. Now ultimately all these will move after d seconds. What will be their location? And then after, okay, I'll say, okay, the location, let's say at last becomes -3, -1 and 1. Now I need to find, okay, the sum of distance, which means from -3 go to -1, 1, from -1 go to 1, which means for all the pairs find the sum of their absolute distance. Cool. Now this is actually the problem itself. Now your main task, okay, let's break it down. Let's say you have got the final location of all the ants after d seconds. If you have got the final location of all the ants after d seconds, then you have to find, okay, the sum of distance of all the pairs, right? Let's say the final location between them is A, B, C, D, let's say up till D. Cool. Now the sum, it is nothing but B minus A, which is the sum of the pairs. For this it is B minus A, for this it is C minus B and C minus A, for this it is D minus C, D minus B, D minus A. I am going to all the pairs. For B it is just one pair, for C it is B and A, B and A, for D it is C, B and A. So I'm going on to all the pairs. So ultimately I just want, okay, if I have the final location of these A, B, C, D, but meanwhile the folks are watching, the folks are liking in, can we smash that like baby to 30 likes? That would be great. Just 3 more. Cool. Now I just want, let's imagine, I'm just imagining, okay, let's say by anyhow I can get the final location of all the robots, then I will land at A, B, C and D. It's a final location. Ultimately I want the sum of distances of all the pairs, so I'll just keep on going and make all the pairs, okay, B, A, C, B, C, A, D, C, D, B, D, A, and so on and so forth. For sure A, B and B are same, so please count that once only, so I'm just counting in the reverse direction. Cool. Now I want the sum of this particular whole thing of all the pairs in what? In O of n time. And I can easily see my n, which means my num's length, is actually 1e5. So I want to find this all the pairs sum in O of n itself, or maybe O of n log n, whatsoever is more efficient. But yeah, that is what we have to do. So if I have the final location and if I want to find the sum, let's say this sum, let's say this sum, let's say this sum, can we think of anything that, okay, if we have this, yes we can, this is nothing but 3 into D minus A plus B plus C. It is nothing but 2 into C minus A plus B. It is nothing but saying, okay, what is the prefix sum up till here? Just say, okay, I am at D, so number of elements up till so far, its index is 0, 1, 2, 3. So index into that number, which is D, minus the prefix sum. And same goes for every number. It will just say, okay, 2, which is I into C minus prefix sum. It will say same 1 into B minus prefix sum, which is A. So by simply using a prefix sum, if I had known, okay, what is the final location like, by simply using a prefix sum, I can go on linearly at every element and we'll say, okay, for this D, let's say if it would have been an E. So I'll just say, okay, 4 into E minus prefix sum. And prefix sum is nothing but A plus B plus C plus D. And as you know, it just keep on increasing. A plus B, A plus B plus C, A plus B plus C plus D. That is how, okay. Now my ultimate aim is, if I have got by any chance these coordinates, these final coordinates, I can simply by using a prefix sum concept, I can find, okay, what is the final answer? What is the final sum of all the pairs? Now comes the interesting part. How will you find the final location of all the aunts? Because while visualizing, it seems very difficult because, okay, one aunt is moving like this. After collision, it just again reversing back. Again, it will just collide with the other aunt. Again, it will just reverse back. Again, it will just keep on going. And here the aunts were just 3. What if the aunt would have been more? It will just keep on colliding, keep on colliding, keep on colliding, and go on. That's what you might be thinking, right? But that's not required. Why? I'll just show you how. Firstly, one reference question. It's a stand question. You can just go and simply watch. But yeah, I'll just show how that is working. If there had been 2 robots, one is moving in the left, right, one is moving in the left. Now you will say, okay, these two will collide. These two will collide actually. And it will just keep on going. It will collide and will again reverse back. It will again reverse back. Right? Right? And with the same speed itself. So nothing changed. It's just that they are just both going and both colliding. Now let's quickly change the color. Right? Just to show, okay, how the collision is taking place. If I have this particular stuff, if I have this road, this is coming in, this is going down. It's going right, it's going left. Now let's say at this location, they both are colliding. So it came here, it came here, it just collided. It will just move back. You saw one thing, everything remains same. It's a ball 1, it's a ball 1, it's a ball 2, it's a ball 2. Now, rather than just saying, okay, they both are colliding and both are coming backwards, if I just say, they both passed each other, 1 here and 2 here. Anything changed? Anything changed? Balls have the same weight, exactly same characteristics, exactly same velocities, everything remains same for sure. I can just say one thing, rather than collision, how about they surpass each other? And it will just remain same, because this ball 1 was going in, it would have been coming in from here. And the ball 2, which was going in left, it would have been coming in as right. But rather than, and for sure, I have numbered the ball right here, but the balls are never numbered. So I can just make them say, okay, this ball 2, it just went in straight. This ball 1, it just went in straight, which means they just surpass each other, never collided. They both are ghosted by one way. So simply, collision never take place. The balls simply went down, just to the 2, it simply went down. The 1, it simply went down. And that is the main trick for this, that collision of the same balls having the same velocity will result in just balls being superpassed each other. By this, what will happen is, I don't have to worry about the collision at all. I just have to simply say this ball 1 will go on for d seconds, this ball 2 will go on for d seconds. Ultimately, it is what will happen ultimately, because these balls are because we saw the 2 balls when collided have the same property as if they would have been surpassed, and surpassing is much easier to actually work on. That's the reason. And see, it was applicable only because the ball surpassing have the same property. They have the same weight, same velocity, everything same. That's the reason. That's the reason it was actually possible to surpass these 2 balls. Cool. And by this, I'll simply say for every ball, if it is starting at, let's say, -2, it's next, which means for sure after d seconds, if it is moving right, so it will have minus 2 plus d. If it would have been moving left and its location is 2, so it would have been 2 minus d. As simple as that, it would be minus 2 plus d. It is nothing but 2 minus d. If it would have been moving left. Ultimately, I'll just know at after d seconds what is the final location of all the robots, ants, whatever you want to say. After having all the final locations, I will just know, okay, these are all the final locations A, B, C, D, E, and F. And we know by using the prefix sum concept, I can easily go and find the sum of all the pairs after knowing the final location, which is this location. And how to know the final location? By simply adding the d time, because at every time it is moving one step. That is how you can simply solve this question. Cool. I hope that you guys got it. Let's quickly go and see the code. It's pretty simple. But yeah, before that, can we reach to 35 likes? That would be great. 35, simply great. Firstly, I'll just keep on going. If it is right, then for sure I will add my d in my actual number, which means the actual location. If it would have been a left, I will subtract because it will go left. So I will just subtract my d from that particular location of that particular element, ant, or robot. Now I want my final answer, which is for sure it can be long, because I want to return modulo with this number. So which means it can be a very big number itself. So I'll have a long answer, which means ultimately I will just do a modulo. But yeah, I need to sort it down because I showed you I need to have a prefix sum concept, which means I will start from the leftmost ant. Okay, then I'll just go on to every ant, and for this ant I will go and say, okay, for you ant, the location of other element is b minus a. For you it is c minus b, c minus a. For it is d minus c, d minus b, d minus a, so on and so forth. Cool. So it's okay to just sort it down. So I'll just simply sort this particular down. I'll just now keep on going to every of those numbers having the prefix sum, as I showed you that it is I into that particular number, which is I, which is you saw in the code, I into d minus the prefix sum. That is simply I into that number minus the prefix sum. And by simply just that, I will have for every element what is the contribution for all the pairs. For this number d, what's the contribution of DC, DB, DA? So that will come for every element, the contribution of all the pairs for that particular element. And ultimately I want the modulo, so I am just doing a modulo of that number again and again, and it's just adding that number in the prefix sum again and again, and we just keep on going to add that prefix sum. And ultimately I can just simply return the answer because it's simply having all the sum of all the pairs. Cool. And that is how you can simply solve this question. Any doubts so far? That would be great. Bro, I didn't understand how you surpassed, because if you surpass, the values are not coming correctly. It will come correctly. See, surpassing is possible because the balls which are coming in are same. If it collides and move back, how about I say, if they just surpassed each other, because the velocity remains same, the mass, the weight, every characteristics of these two balls remains same. So for sure, rather than colliding, you see, I just show you, if this would have happened or this would have happened, you would have never known that if it is coming as different or same, because velocity is same, characteristics of those two balls is same. That's the reason I can simply say these two balls coming in can surpass directly. Cool. Center of mass, yeah, that is correct too. If any other questions, yeah. Meanwhile, can we reach to 35 likes? Just one more, yeah. We are quickly going on to question number 4. That would be super. Yeah, thank you so much. That would be super tricky. It's actually a tricky question. So basically, cool. We have in the questions. You are right. Thank you. I need to see before solving. Other question that you need to see before solving. Yeah, it's good to actually know this question 3 earlier. Because see, please still stay. Please make sure that you remember this concept of. But yeah, it can have quite a lot of modifications. Let's say I just say the velocity of a rebound is different, the masses of these two balls coming in are different, the strengths of these two balls coming in are different. When the characteristics of the ball change, the question can turn out to be a stack question itself. So that is how the question can become complicated, by just changing the characteristics of these two balls colliding in. If I just say randomly, the after collision, the new velocities will become, let's say, v1 and v2, and those velocities are dependent upon the mass of the two balls. So that will become a question E or question D of code forces like level. So yeah, that is how the complexity of this question can change, by just changing the attributes or the characteristics associated with each ball, each ant, or each robot. Cool. That is how you can simply solve this. Conservation of momentum. Yeah, the complete physics you are going to apply here. That's good. Grade 2. Let's quickly jump on to question number 4. It's actually easy to find a good subset of matrix. You are given a zero indexed m cross n binary matrix called as grid. Now let us call a non-empty subset of rows good. Remember, non-empty subset of rows. I have to choose a subset of rows, and that is called as good if the sum of each column of the subset is at most half of the length of the subset. Which means if the subset length is, let's say, k, for each column, the count, if the sum of each column, should be less than equal to k by 2. Cool. Which means if, let's say, that you have chosen 4 rows, so the sum of every column of those 4 rows, sum of every column should be 2 or less than 2. Cool. That is how you can simply say, okay, you can choose that particular subset. Now, more formally, if the length of the chosen subset of the rows is k, which means, okay, if you have chosen 4 rows out of, let's say, n rows and 4 randomly chosen like rows, then the sum of each column should be at most k by 2. Cool. You have to return an integer array containing the rows indices, which means, okay, what all rows you can choose in of a good subset sorted in ascending order. Okay, cool. Just giving out what is the subset of rows that you can choose, such that the column sum is less than equal to k by 2, which is if you're choosing the k rows itself. And it is just saying, okay, what is a subset like? You should be knowing what is a subset like. Subset, okay, if I have rows, let's say, as 0 1 1 0 0 0 0 1 1 1 1 1, I can choose, let's say, 1 or 3 rows, 1 or 2 rows, like any rows I can choose, and that will show me, okay, that is a subset of rows being chosen. In total we have 3 rows. I can choose any rows in general randomly, let's say 1 and 3, so that will become one subset of a row. Cool. Now you have these now you have the rows for sure. Looking at the constraints, we can see, okay, we have n rows, for sure. Okay, it says m columns and n rows. N is nothing but 5. I have m columns. I have to choose a subset of rows, which means I have to go and maybe for sure I can't go and choose every such subset of rows. It will become push power m. Not possible at all. First thing comes in a mind is dp. Let's try to think of dp applying. Let's say we apply dp, we just find, okay, if that row is possible with the other row. For that also, it will just try to go and do a m square, or maybe the way you think of the dp and bit masking together, how it will just gonna go, that can differ. So thinking like dp might not work. Because see, you choose a row, then you have to go and choose another row. How will you choose another row? Such that, okay, You will just try. One thing is go and randomly choose any other row, which means I'll just go and randomly choose every other row. It is one very basic concept which comes in the mind. Okay, for every row, I will just go and try to use every other row, and maybe I'll just try to memorize it so that it doesn't go and check for other rows again and again. It is one thing which comes in our mind is, but to go and check for other row itself, it will take O of n square at least, O of m square, sorry, O of m square at least. I will just get confused by m square, n square, because for me, n is always rows and m is always columns, but in the question itself, it's m rows and n columns. Cool, no worries. But one thing is for sure, okay, I can't go m square, which means I can't go and say, okay, let's start from this row and then go and check, okay, what all rows can be possible. That is something will actually not help me to actually think. So can I think of something else? I need to compute it in O of m only, or at max O of m into n, or n something, because n is very small, n is 5. So I can just say n for anything, but I can increase n to, let's say, n square or n cube or 2 to the power n, anything I can have. But yeah, m is one thing I cannot increase, which means I can go to every row exactly once. Every row exactly once. Can I find a pattern? Because the condition given was this, right? One thing is very much evident by this. Let's try to make this condition as false, which means I'm saying my sum of every column, which means my sum of every column, it should be less than equal to the, which means if I choose the row, let's say 1 and 2, so the sum of this column, it should be 1 or less than equal to 1. It is 0, 1, 1, 1. Cool. If it would have, I would have chosen, let's say, if I would have chosen, sorry, let me quickly close this down. If I would have chosen, then it would have been 2, but the rows chosen are also 2. It would have said, okay, rows chosen are 2, which is k, which is 2. So the sum should be less than equal to k by 2, which is nothing but 1, or less than equal to 1. One thing I can infer from this is that if I'm choosing a row such that its element is 0, okay, it is 1, then I will have to choose another row such that its element is 1. It is 0, which means it should be complement of that particular row. And why Aryan that is needed? Because for sure, if you're choosing these two rows, then what can happen is, if it would have been a 1, then it would become a 2. And you want, okay, the rows are 2, the sum should be 1. So for sure, 1 should be 0. But let's say you will say, okay, Aryan, what if I do something like this? If it is a 0, I will just say a 1, 0, or I will say a 0, 0, so that you can choose all 4 rows. Yeah, you are correct. But I will again say, it would have been a better chance that you would have only chosen row number 3. It's a simple 0, 0. Or I would have said, okay, let's choose this 2 rows. Why choose this at the first place? So one thing can come in your mind. I'm not saying it is actually correct. I've never proved it. It's just an intuition. For every, if in a row, if I have a 0 and if I have a 1, for that one, I will try to choose a row which has a 0. And for sure, the other part, it can be a 0 or a 1. Okay, it can be a 1, let's say complement, and it would work. For sure, it would work. A 0 also, it would work. Cool, no worries. But a 1 for sure, or a 0 for sure, it will work. Which means if it would have been a 1 again, and I would have said, okay, it's a 0, 0, 1, it would have still worked, because ultimately it would have just said the sum is nothing but 1. So one thing for sure coming in our mind is, for my one number as 1, I will try to use another row such that its digit here at that location, the binary number, it should be a 0. That seems correct. But Aryan, it means that, okay, it means that for every row, for one row, I will just try to find some other row such that the AND operation is ultimately a 0, which means ultimately what I'm thinking right now by simply saying, okay, if I choose one row, other row should be such that if here is a 1, here should be a 0. If here is a 0, then I can have a 0 or a 1. I can have a 0 or a 1. But if I'm choosing this row, then other row, it should look something like this. So that if it is something like this, I can simply say, okay, these two are my final rows as the answer. Which is ultimately I'm saying that ultimately I will have 2 rows and that would bring my answer. 2 rows would bring always. I'm saying I'm now bringing to a point. 2 rows will always bring my answer. What if I have all zeros? Yeah, for sure. Only, okay, if all are zeros, then one row can also bring my answer. But now I'm saying either one row, which means all these zeros, or 2 rows, which means such that these 2 rows, the AND operation is itself a 0. These 2 rows being chosen can bring my answer. I can bring my 2 rows as the answer. Now, we thought initially, okay, for a row, I need to have another row such that its numbers are just, okay, if it is a 1, it should be a 0. If it's a 1, it should be a 0. If it's a 0, I can have anything, 0 or 1. So for sure, if I can find such 2 rows, such that it is a AND operation, it's itself a 0, I am good to go. But, Aryan, we just start to think, but is it actually true? It would happen. Is it actually true? Which means, is it actually always necessary that, okay, 2 rows will for sure bring that answer? I'll say, let's prove it down, right? Cool. So for that, I will place all 5 numbers. I will have all 5 numbers because it's a maximum. It can go 5. Now, to just prove this wrong, that 2 rows can never bring the answer, I will try to make 4 rows. I am solving it by contradiction. Firstly, by intuition, we thought, okay, if it's a 1, I should have a 0. Okay, if I have a 1, I have a 0, which means only 2 rows are actually required to bring the answer. Now, it's actually an intuition. But to prove that, I have to prove it by something. Either I can have a valid proof or I can have a contradiction. But yeah, before that, if the folks are joining, liking it, can we please actually move that like count to 45? That would be great. 45, that would be great. Cool. Now, to prove that by contradiction that, okay, maybe more than 2 rows would be required, let's go and see how actually that would be used. So after 2, we can have a 3 or a 4. If we had a 3, for sure, if I add a row 3, then it would just say, okay, if let's say a 1 is added, so still it would have not mattered because it will just say the row count is 3, so still it should be less than equal to 3 by 2, which is actually 1. So for sure, 3 would not help us to visualize, okay, if it should actually impact or not. So I will quickly go and say, okay, let's try and see if 4 rows are actually required or not. And I will try to build an example such that at every point I am building an example such that every row should be required. Because ultimately my aim now is I will try to build an example such that all 4 rows are required. Because I thought initially by concept that, okay, maybe 2 rows are actually more than sufficient. But to prove that, either I can go by contradiction, which means, okay, 4 rows can never be required. 4 rows can never be required to actually make it as the pair which we want. Or else I can simply make a other proof by itself. Proof you can actually make, but yeah, I am here going by contradiction. I will try to make the worst possible, which means, sorry, the best possible example such that all 4 rows should be required. How? Let's see. Firstly, if I want all the 4 rows to be required, then every row should be dependent on every other row. Cool. If I have a 1, I want, okay, for sure some other rows should also be required, which means all 4 rows should be required. So for sure, here if it is 1, 1, then for sure I should have a 0, 0 also. Because if I choose a row like this, then it will never count. I have to choose all the rows. If I would choose a row 1, but Aryan, now it might happen that you might choose the row 3. Cool, no worries. I will put a 1 here. Now you can never choose a row 2 and row 1 and row 3. Let's place a number. It's a 1, it's a 2, it's a 3, it's a 4. So you can never choose a row 1 and a row 3, because for sure then the count will become 2, which means, but for sure you want the count as 1. So you have to choose all the 4 rows. Cool, no worries. Aryan, what if you choose 1 and 4 row? If I choose 1 and 4 row, if I choose a 1 and a 4 row, then it would be, let's make something like this. It would become a 0. It would become a 0. I can simply say, okay, I cannot choose my 4 rows, 1 and 4. Now, why I can choose 1 and 4? If I choose 1 and 4, then simply it would just need me to find and say, okay, addition to sum, just take more rows. For sure, it can't be possible. Now, for 1, it is now required to choose row 2, row 3 and row 4, all of them. If I choose a row 1, but Aryan, wait a second, you can now choose row 2 and row 3. Yeah, I can. Now try to complicate it, which means place a 1, 1. Now you cannot choose row 2 and row 3. Because now I'm not concerned about row 1 at all. Because for sure, row 1 can never be chosen now with any other row. If row 1 is chosen, all the rows needs to be chosen. Now I'm trying to build examples such that for row 2, it should be such that all the 4 rows should be chosen. For row 2, earlier I saw, okay, row 2 and row 3 were actually compatible. So I added a 1 in their count such that now row 2 and row 3 are never compatible. So I need to choose all the rows for my row 2 to come as my answer. For now, but again, I can see that for row 2 and row 4, still row 2 and row 4 are compatible. So how about just complicate that also, which means row 2 and row 4. Cool. Row 2 and row 4 are now also compatible. Not compatible, sorry, which means for row 2 and row 4 to come in, I need all the 4 rows. Okay, cool. All the 4 rows are required. Row 1 is done. All 4 rows are required. Row 2 is done. All 4 rows are required. Row 3 is only left, which means for row 3, and I could see my all 5 columns are filled in. For my row 3, if I would have a chance such that I would have placed a 1, 1, 1, 1, then I could have just spoken, okay, now row 3 and row 4. For that row 3 also, I need all the 4 rows. But I don't have any other options because I have only 5 options to place in. So I don't have any other options to place in. So for sure, row 3 can always pair with row 4, which means 2 rows will always remain. 2 rows will always remain such that they will make a pair. They will make a pair. 2 rows will always remain such that they can make a pair such that you have your 0, 0, 0, 0 and 0. You have your that operation of getting rows subset such that length, the count of columns, it should be less than or equal to k by 2. It will always happen, because if it would have been a 6 columns, then maybe all 4 rows are required. But if the columns are only 5, then I will have only these conditions. 3 conditions for this, 2 conditions for this, and 1 condition for this. So basically, to make 4 rows, I need 6 columns. That is how for 4 rows I need 6 columns, but I only have 5 columns. That is how I will just say I only require 2 rows. I only require 2 rows at max to bring out my answer. And that is how we can simply solve it by just saying, okay, either I require 1 row, which is simply a 0, 0, 0, or I require 2 rows, such that if one row I choose, let's say this row I choose, let's say as R2, then other row I can choose such that the AND operation between these two rows is actually a 0, right? It is simply what I have to do. But Aryan, now you know, okay, you have to choose. Yeah, for sure. If the folks are watching and liking in, can we please reach that like count to 45 likes? That would be great. Super great. Cool. Now I know, okay, if I have m rows, so for all the m rows, if I have m rows, so for this row I have to go and check for other row such that the AND operation between them is 0. It is one thing I have to do. That is the one thing I have to do. Or itself, I can go and simply iterate and say, okay, if any row it's itself all one, if it is all zeros, then also I'm good to go. Or else other option is simply go and check for this row, let's say this R1, go and check for other rows, let's say R2, R3, R4, R5, R6, go and check, okay, if the AND operation, if it's actually a 0. But I can't go m square because m is actually 1e4. So for sure, I need to think of something such that if I have this number itself, by this number itself, I can go and check if there is any other number which can complement me, any other number. You will just easily see that the array itself was of size 5, right? Size 5. Which means this number, if I convert this particular array into a binary representation, then that can have 2 bits, 2 bits, 2 bits, 2 bits, 2 bits. So in total, it can have a 32 options, which means from number 0 to number 31, it can have the options. So ultimately, this particular row, if I convert that to an actual integer number, okay, it is in the binary form, which is actually 0, 1, 0, 1, 0, 1. If I convert that to actual number itself, then it will lie from either 0 to 31. Don't you think that it can help you out? How? Simply I wanted, okay, for every number, for this number, let's say I converted this number to an actual integer number. Let's say it comes as 26. I converted the number to an actual number, integer 26. Although right now the number itself is a 31. But I'm saying, okay, this number, it can vary from 0 to 31, right? It can vary from 0 to 31. So now my task is, by anyhow, if I can find out if that number has any other number such that the AND operation comes as 0. So that is so simple, right? How? I can simply go and check, okay, what is the integer representation of this row, this row, this row, and this row, and this row, right? Let's say this row right here has the number, let's say as 17. It is, let's say 26. It is, let's say as 30. It is, let's say as 24, any number. If I just make it, basically I'm converting the binary representation of that row into actual number. Okay, I've found the numbers itself. Now I just want 17, that number, it needs to do an AND operation with other number. 17 and other number, if it is a 0, and that other number, it should be present. So I can go on and check for every other number, which means from 0 to 31, I can go and check if that 17 and 0 is actually a 0. Yeah, it can be a 0, but for that the 0 should also be present so far. So I can keep a map which will actually keep track of every number present so far. Now I can keep a map which will keep the track of every number present so far. That map will say, okay, 17 AND operation I can do on number. So basically I'm trying for every number from 0 to 31, because I know the numbers above it can range from 0 to 31. And if that number I'm about to add, if it had already come or not, by simply using a map, I can use, okay, if 24 has come, so the frequency of 24 is increased, and just say, okay, 24 is available for you to do an AND operation. Now, if on doing an AND, I get a 0, I can simply say one fact that, light has gone, but still, the video will still go on. I can simply say one fact that my 30, I can simply say one fact that my 17 and 24 is actually a 0. If that is the case, I can simply say that I have two rows. One row is this row, let's say R5, and one row is this row, let's say R2, which can actually give me the final answer. So you saw, firstly, how we started with the intuition itself. Okay, if we have a row having a 1, so for sure I need to think of other row having a 0, and there is no point of actually putting a 1 itself, because for that 1, if I put in, I have to again go and find for another 0. So it's better to think of, okay, if I have a 1, let's think of getting a 0. Now, okay, I just think of 1, I just got a 0. Good. By that I realized that at max 2 rows are more than sufficient, but it was just an intuition. I need to prove that part. I tried to prove it. I took the 5 columns. I tried, okay, if I was saying for 2 rows, if it's possible, let's try to make an example such that 4 rows are always compulsory. I tried to build an example such that 4 rows are always compulsory, but by building that example itself, we realized, where's the example gone? Yeah, by building the example itself, we realize that even if all the 5 columns we tried to put in very, very, very sharply, still it would remain such that one pair will still remain. It will still satisfy the condition that you can simply do an AND operation and will get a 0. So for sure, it is possible that I can just simply use two rows to actually prove the fact that I can bring in the answer for this question. So now I realize I can use either 0 rows, either one row which have all these zeros, or I can use 2 rows such that the AND operation between them is 0. Now to choose 2 rows out of m rows, either it can go m square, but then I realized that, okay, I have also constrained that every number, it can at max vary from 0 to 31, because it's a 5-bit binary representation. So if it's a 5-bit, so the number can range from 0 to 31. So rather than iterating on m values, I can iterate on 32 values, right? That will bring my answer to 32 square. That's simple. So I will just go and say, okay, for any row, let's say if I am at R5, for that row, if I have the value of that row as, let's say, 17, I will try and do the AND operation with all the numbers from 0 to 31, provided that number is actually occurred before. If that number has occurred before, let's say 24 has occurred before, and this result in a 0, I don't know if it's actually or not, but yeah, if it results in a 0, I can simply say that, okay, my row 5, it's an answer, and also the row 2, which is represented by 24's location. 24 location is nothing but R2. So for every number, I can just place in its location, let's say R2, or every other location, and for every number, let's say for every number of a row, I can go and check for numbers from 0 to 31 and see if that number has occurred before or not. If yes, then if its AND operation is a 0 or not. If yes, then simply go and say, okay, what is the row number for this number 24? I will have another map for that, just giving me that another row, let's say row 2, or you can do any ways. Either you can have a map or not, or any ways you want. I have a row 5, I have a row 2. I will simply say, okay, my R2, which means my 2 and 5 is my answer. Or else at any way in between, I find any row with having the number as 0, which means all the numbers are 0 here. I can again say that that answer row is actually that row number 6, R6, because it has all the zeros. That's how we saw if we can have one row or 2 rows. Cool. I hope that you guys got it. If yes, then do smash that baby up. That would be great. Let's smash that baby to 50 likes. Just 2 more likes. That would be great. We'll quickly jump on to the code. It's pretty simple. But yeah, before that, let's quickly see your doubts and stuff. If you have center of mass conservation, भैया वो cool बोलना थोड़ा कम करो, please. Cool. I thought question 3 is a DP question, but was not able to find out the base condition. Question 3, why can't DP be applied on here in D? If you want to apply DP on question number 4, then how will you think? Okay, you will start from one row. You need to go on every other row. At least one other row you have to go on to just check. Okay, if that, and maybe you can just say, okay, Aryan, I'll just have one row and maybe I can just go and apply my DP on some other row by seeing the bits. Okay, if I have the bit, let's say as 1, other row should have the bits as say 8 or 9. So by that itself, again, you have to go and revert back on the logic itself that, okay, if you are only using 2 rows, or you are saying right now that you can use m rows out of n rows. Sorry, you have m rows, you are using, let's say, x rows out of it. Then for one row, you have to go and find the combinations of other rows. For that, you have to maintain these subsets itself. Maintain the subsets itself. And to have that in just O of m or O of m into n, it's impossible, because to keep track of at least one other state, you will again need an O of m. So O of m squared it will become, or maybe O of m into more than m times. So just bringing the state of DP out also would be very difficult. It can be possible by doing some modification in bits, but to think that deep was actually a bit task. And meanwhile, while thinking itself, you can bring out the logic that for 5, only 2 rows are more than sufficient. If the columns would have been 6, then the answer would have been, okay, either the rows would have been 1, 2 or 4. That is how you can simply solve it. So for every of those conditions, which means when columns are increasing, my actually conditions on rows will also increase. Cool. I will explain that. Cool. Can you explain if k by 2 is more than 1? K by 2 is more than 1. Yeah, like that I explained entirely. If your k by 2 is more than 1. भैया कमेंट्स क्यों नहीं पढ़ रहे हो? कमेंट्स पढ़ते हैं बट बाद में. आर्यन कुकिंग व्लॉग प्लीज. I don't know, Vamsi, how come you know so much, but yeah, I cooked recently. I don't know how he knows that part, but that's a strange fact. If a row has 0, 0, 1, 1, 1, why can't we return that row? Because for sure, the count of the sum of columns of the last column and the last second column, it's actually a 1. If it's actually a 1 and you want, if the row count is 1, then you want the column sum to be less than equal to k by 2. My k is 1 by 2. The column sum should be less than equal to 0. So it can only be a 0. So one row, if it is present, it should have all the zeros. That's it. Thank you for your understand. Thank you, understand. Cool. Was not able to come up with this approach during contest. No worries. It's hard to come up in the contest. Yeah, that's correct. Cool. Let's quickly jump on to the code itself. It's pretty easy. But yeah, before that, if the folks are watching in and liking that part, can we please reach to 55 likes? That would be great. Super great, yaar. Cool. Let's quickly see. Firstly, I have my n and my m. Remember this. My n is nothing but my number of rows and my m is nothing but my number of columns. So please make sure that my n is rows, my m is columns. Now I just use this map as I showed you. Why I use this map? Because for a number, as I showed you in the code also, that for a number, let's say 17, I need to know if I'm iterating on all the numbers from 0 to 31. if that number 24 is present or not, if that number 26 is present or not, if that number 0 is present or not. So to know that part, if that number has occurred or not, I'm using that map. Cool. Let's quickly go. So I'll just quickly go on all the rows, because for sure I want to go on all the rows and see if that row value is, let's say, x. So x, and if any other value from 0 to 31 has occurred before and that AND operation result in a 0, I'm good. So I'll go on to that every row. For every row, I'm going to find the value of that row. What I mean by value of that row, I know that row is a 5-bit number itself, is a 5-bit, because it's a binary representation of 5 columns. I can say it as a 5-bit number. 5-bit number is from 0 to 31. So I can just go and find the value of that row is in a number form. Cool. I'll go and find the value of that row in a number form. To find that, I'll go on to the column for that particular row, and just going on to the column, I will just simply do a left shift operation to just go and simply say 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and so on and so forth, and simply get the value of that particular column. Now, as soon as I have the value of that column, of that row, I have the value of that row in the integer form, converted that row which is of zeros and ones into a integer number. So that row is having a value now as val. Cool. Now, if that val is 0, which means all the numbers would have been 0 in that row, simply return that row itself. That is your answer. But if it is not the case, then I will go and try to find, okay, for that row, the value is val. Now I want val, I want val and some other number which is from 0 to 31. If that AND operation is a 0, which means, and also if it is a 0, if let's say at random I choose an integer I, so that I should also be present, which means my map of I should also be a 1. Cool. Then I'll simply go and say, okay, if I will go on to every number, which means every j I'm going on for this val. For this val, if val and j is a 0, and also that map of j should be a present, which means my map of j should actually be present. If that is the case, which means my j is actually present in my map, and my map is simply showing the location of that particular number, which means if I just say, okay, the number 26, let's say I is 26, so val and 26 should be a 0, and also 26 should be present, and if present, I also want to know the row of 26. So I can simply say in my map itself, my 26, either I can have two maps, one will use as a count, one will use as a row. Okay, what's the row location? Or I can simply use one map, which means if that map is populated, okay, that 26 is present and have the row, let's say, as 3. So if the val was present at the row 8 and that val and 26 was a 0 and 26 was also present, which means by saying, okay, it's at a row 3. So I'll say, okay, ultimately I have a row 3 and a row 8 as my final answer because their AND operation is a 0. Cool. If the folks are watching and liking, can we please reach 250 likes? Just three more likes. That would be great. Let's quickly go back and see. I go on to every j and see if the val and j is a 0 and also the j is present in my map. If that's the case, simply go and say, okay, the row of my j. Simply say what is the row of my j, and also I is for sure a good row because I row has the value as val. So value is good. My value j is at the row of map of j. So j is at the row of j is nothing but map of j is the row, and I is the row where the value is val. So val and j will give me the row as map of j is the row of j and I is the row of val. If it is the case, which means if val and j is 0 and also my j is present in my count in my map, just simply return. Else if not, then simply go and update your map of that value, because for sure the value is the actual number integer value of that row with that row itself, because my map is storing the row of every value. And ultimately, if not possible entirely, then simply go and return the empty my vector, and by this you can simply solve the answer. Cool. I hope that you guys got it. It was a bit tricky to actually firstly think of something which can be applied, and then thinking of, okay, if I have a 1, how to bring a 0, if I have a 0, how to bring a 1. Okay, by then thinking, okay, it should have 2 rows. Now it is one thing we assumed, we have to prove that wrong also. Maybe it is wrong, so I have to prove that fact also. To prove that, we can actually go and start proving, or actually we can go by contradiction, which means make an example such that it is proving everything wrong, which means it should have 4 rows for sure. But while building the example very carefully, we saw that it's never possible that the 4 rows will be required. So for sure, either rows required a 1 or a 2. We can simply say the rows required a 2 or a 1. And now the task is, okay, how to choose 2 rows. No, we know the AND operation should be a 0. If the AND operation is a 0, then for sure we have to do something. AND operation is a 0, we have to do something. We can't do m square algorithm, which means we can't go to every row again and again. We can't do O of m square. We have to do an O of m into n or something like that. We saw, okay, that number is a 5-bit number, so for sure bit masking comes in picture. That, okay, I can convert that row into a number itself, into integer itself, and then use that integer to actually go and find the answer. I use that part to actually go and see, okay, for that value, other number integer, it can be only 32 times, only 32 numbers, different numbers, and that should be a 0. If it is the case, go and simply find it. Simply find that val. If you find a val and a number, that number should already have been occurred in your particular rows, and if occurred, you should be also knowing the row of that particular number, because its row is nothing but I, its row is nothing but by using the map. Simply by that, you can simply go and find the rows of both the numbers, and that would be answer itself. Cool. That would be great. That the contest solution is finished. Anything else you want to ask? That would be great. We will be ending the stream in 3 minutes. So yeah, we can quickly wrap up. That would be great. But yeah, before that, if the folks liked the entire proof and also the intuition of how to think and how we prove that it is wrong, it is right and can never be wrong, and also then how we optimize that approach of m square to actually O of m into n into n, O of n into 2, O of m into 2 raised power n into m. That's a final, because into n, n into n, because n is 5, m is 30, m is 24. So that is how you can simply solve this particular algorithm. If we can reach 60 likes, that would be great. Just 4 more. It was a tough contest. Yeah, that is correct. What will happen if n is at most 10? Then for sure the possible options will come as either 2, 4, 6. I guess 6 would be suffice. 2, 4, 6. You have to just check. Okay, 4 will for sure come. 6, you have to see while making that graph that, okay, how it is coming in or not. Watching live lately. In third question, why is needed to sort the array? I didn't get the answer. Yeah, I didn't get the answer without sorting. See, if you have to go, if I quickly just go and show you, is my screen up? No, it is not. See, if you will not sort it, it will say the nums as random, while you say that it was ABS, right? So for sure, this will make sure that my I into my nums of I, if it is sorted, my prefix is always less, and my nums of I will be more. So nums of I into I, which means, and for sure it is nothing but prefix. Prefix is having the smaller values and at max I times. So for sure it will be more than this particular prefix. That's the reason you have sorted it so that you can easily apply this operation. Else go and simply go and do ABS and stuff and you will get the answer too. But yeah, that is not required. You have to simply go and do the ABS to every other part. Just a bullshit, because for sure not simply an ABS will help you, because that's ABS. When I mean ABS, I mean ABS of every part, which means I'll again show. I mean ABS of every part, which means if I just say, go and say D minus C, D minus B and D minus A. What if your B would have been somewhere here, which means B? How would you do ABS of D minus A, ABS of D minus B, ABS of D minus C? How will you do when your A, B, D, A, B, C and D are all different? Which means then you have to go and individually do this particular operation. But now I know my D is always more than A, B and C. So I can simply do a 3 into D minus A plus B plus C. So as to not go and do the pairwise operation again for every number, let's say for D, to go and do it again and again, I have to sort it down so that I can simply convert this ABS operation, because it is nothing but ABS plus ABS plus ABS. It can only be possible when I know, okay, the thing 3 into D is always more than A plus B plus C, because it is always more than 3 into C, and that 3 into C is always more than 3 into B. It's always more than 3 into A, because A, B and C and D are sorted. That's the reason you have to sort it to actually do this particular operation right here, right? You have to sort it down. Cool. I hope that you guys, that Pranay, you got it. Aryan, I'm practicing for the past 10 months. I'm still trying. I'm literally crying every day to set my mind properly to solve the problem. See, it happens a lot. We just have to practice and learn. See, you learn this ant problem, right? That problem of robots. Please go and paste that somewhere in your code or anywhere in your notes. Okay, I have studied this problem, because 8-9 months later this will come again. For sure, have that in writing. This problem will come again, and again you won't remember how you solve this problem. You will just remember, okay, Aryan told something, it was a tricky question, I could not solve it. Again, I'm still not remembering how to solve it. That is how you know that you have to keep notes of stuff. Cool. I'm producing that's cool. My D is always more than A. My D is always more than A plus B plus C. Interesting. Cool. I solved the fourth question, but the third was actually very tricky. Yeah, for a few of them, fourth was tricky. For a few of them, third was tricky. But yeah, third and fourth both were tricky, but we saw both of them. Cool. We would be ending the stream. That would be great. Can we reach to 65 likes? Can we reach to 65 likes? That would be great. That would be so lovely of you guys. We saw all the 4 problems. That was it. See you in the next. Goodbye. Take care. Bye. Problem solving कैसे अच्छा करो? Please help us. Problem solving भाई अच्छा होता है problem solve करके. So just getting the problems, learning from them, solving more, giving more virtual contest, learning more from those problems, and that's how we can solve and we can get better at problem solving. Give more problems, give more contest, and that would be great. Cool. It was a good contest. Yeah, that was actually a great contest. Legit a great contest. Cool. Thank you so much for joining in. That was so great to meet you guys again. See you tomorrow. Contest discussion for sure. Pranay, for sure we will see you tomorrow. If we can reach to 65 likes, just one more, that would be great. Cool. Bye bye. See ya. Good night and see you tomorrow. Bye bye. यार बड़ा मजा आता है तुमसे बात करने में यार, पता नहीं. Cool. Bye.